Hello everyone, so this is going to be the second section of our HLD playlist, and this section is divided into two videos of rate limiters. In the first video we are going to cover about the definition and the problem requirement of the rate limiters, and we are just going to discuss where we are going to put our rate limiters and some concepts. And in the second video we are going to discuss about the algorithms and the whole design, how rate limiter is going to look. So without wasting any time, let's get started and study. So if I talk about the basic definition of the rate limiter, so rate limiter is going to limits all the requests if they are going to exceed a particular threshold in a specific time. So what do I mean? We're just going to understand it with an example. First of all, let's see a general scenario. So suppose there are two users here, user 1 and user 2. They are going to hit with our server with 10 lakh requests per minute. So there are a lot of requests that are coming to our servers that are 10 lakhs. Now I just mentioned two users, but there can be a scenario where there are multiple users, like thousands of users are going to hit our server with 10 lakh requests per minute. So what will happen in this scenario? When there are a lot of requests comes to our server will go down. The latency will increase in our server because our server will not able to handle the load. So suppose, let's assume that our server is able to handle approximately 10 requests per minute and we are getting 10 lakh requests per minute. So how our server is going to deal with it? So we need something in between as a barrier, as a wall that can protect our server, that can protect all the overloading that is happened on our server previously with these clients. So we need a barrier. So here the rate limiter comes in the role and saves our server. So rate limiter says to all the clients, have a break, have a KitKat, and now rate limiter acting as a wall here and saving our server. So let's understand this diagram now. So again, the clients are sending you the 10 lakh requests per minute. Here they are sending it, and now rate limiter is acting as a barrier, as a wall here. And what it is saying to all the clients, now you're sending me a 10 lakh request, but I'll make sure that only 10 requests will reach to my server. I'll just make sure whatever the server told me that I can handle that much request. If the server told the rate limiter that I can handle 5 requests per minute for a particular user, then the rate limiter will make sure that these much requests can reach to the server. This is how rate limiter is going to act as a wall. Now let's discuss about the advantages and disadvantages of the rate limiter. First advantages that I just discussed, that prevent overloading of the server. We just saw that example how rate limiter is acting as a barrier and saving our servers. Rate limiter is also saving the server from the DDoS attack. So it is a pretty simple example. When there is a multiple users or one user is going to attack our system or bombard so many requests on our server, again rate limiter will act as a wall and saves the server, and only genuine request, only very limited requests can reach to the server, and all the other requests will be blocked or marked as invalid. Now comes to the third point, that is fair resource allocation. So again I told you the server is going to define that how many requests it can receive. So suppose server 1 says that I can take up to 10 requests, server 2 says that I can receive up to 20 requests per minute for per user. So what will happen? So rate limiter will make sure that to server 2 20 requests will reach in a minute, for server 1 10 requests will reach to a minute. So rate limiter will make sure that requests are reaching to a server according to the configuration that they have mentioned. So this is we can call it as a fair resource allocation. Now moving to the disadvantages. So there are disadvantages of the rate limiter. So let's discuss about the first one, that it increase the latency. So there can be two scenarios, like we really don't know where the rate limiter we are going to put. Either we can put it in between the client or the server, like it can act as a middleware. We can put it with our code. We are not sure about it until now, but wherever we are going to put it, it is going to increase the latency because we have to add some additional logic in our code, that either this request is going to reach to the server to our code logic or not. We have to put some logic. So that's why it is going to increase the latency. Wherever we are going to put the rate limiter doesn't matter, but this is going to increase the latency anyhow. Now let's discuss the case of potential for false positive and excessive blocking. We are just going to see an example of these second and third case together. Let's understand it. So suppose we have three users, first, two, and three, they're using the same public IP. What that means that using the same public IP, it means that they are under the same internet connection. Simple. And when they are going to hit our rate limiter or our load balancer or anything, the call will reach to our rate limiter and then to our server. This is how it is going to look. Now what will happen? When the requests are coming from these public IPs, we know that these users are not logged in right now. We are just considering that these are just some random users hitting our server. And in this scenario, let's take an example. We set up a rule in our rate limiter that only 100 requests can reach in a minute. Simple rule, 100 requests in a minute. So if I draw a single line of 0 to 60 seconds, so what happened? This third user make 100 requests in 30 seconds. So these are genuine requests. So like our system will assume that this third user can make up to 100 requests in 60 seconds. So our rate limiter will allow them. Now what happened on the 31st second, or like assuming that the second user come at on the 40th second and tries to make a request. So will we able to process it? Now it is going to be 101th request in 1 minute and we cannot process it. But second user is a genuine user and it is going to be its first request. So in that scenario, we are just going to deny it. And this is a case of the second point, potential for false positive. It is a genuine user making a genuine call, but still not able to make an not able to reach to a server because the rate limiter is saying no, all the quota has been expired. Again, there is one more problem, that is the whole public IP is blocked in this scenario. So all the other users can also not make the call, but these users are genuine users. So excessive blocking of the IP. Only one user, only the third user is making abuse to a system, but we are just blocking the whole IP. So let's see in the future that we can resolve it or not. Okay, so this is one of the disadvantage of a rate limiter. Now let's understand the problem required, what we want to build. So first of all, we need a simple rate limiter. The algorithms that we are going to see in our next video, but we need some sort of a rate limiter that we are going to put and where we are going to put, of course. Second point, so we need low latency because we have a core logic in our servers and we need something that can simply just tell that either this request is allowed or okay. So now we have some other common features also, like it should be available, it should be distributed, like it should scale down and any other things. We'll just see them later on, but these are just normal requirements that are common in every single design videos. Now let's understand capacity estimates for it. So if we discuss about a normal scenario, like if we have 1 billion users and our rate limiter is protecting 20 services. So 20 services, I mean, like suppose there's a login service, authentication service, there is a service of like creating a post, like watching newsfeed or anything, like there is like an Instagram app and we are just our rate limiter is protecting the whole 20 services with it means that there are 20 features. Now the third point is like user ID is going to be like we are considering that it is going to be long of 8 bytes and there is going to be a counter that is of 4 bytes. We can just take the counter of 8 bytes as well, up to you. Now if we just multiply all of them by 1 billion into 20 into 8 plus 4, that is give you 240 of GB of data. So it is not that much. So I guess we're just going to see later on how we are going to store all these things. Now let's move to the concepts and let's take some basic understanding. That is going to be the last part of this video, and in the next video we are just going to see and jump to our algorithms. So first thing that you need to know about the first point, that is, are we going to put it on the user IDs or are we going to put it on the IP address? So first point that I mentioned, like here in this con case, we are rate limiting on the IP address because we don't know the user ID. So of course we have to go with our IP address. But if we know the user ID, we can go with the user ID as well, because then it will be very specific to a user. Now, the first scenario, when we go with the user ID, it is pretty good, easy to track, bad user can be blocked. We can say simply mapping everything on the user ID. But when we are going to get a user ID, of course we can get a user ID only when the user is logged in. When the user is going to be logged in, then only we get an authentication token, and with that authentication token we are able to figure out the user ID of that user. When we get a user ID, then of course we can put a rate limiting logic on that user ID. Now, but what will happen if we use a IP address? So suppose the user is not logged in, and like take an example, if there is a service in which user is entering a email ID and password and trying to click on a sign in button, and like keep on clicking on a sign in button again and again and again, and a lot of users are doing it, so they don't have the user ID. So we can block the user in that scenario on the basis of IP address. Or like there can be one more example we can take, when there is search functionality and the user is not logged in again, and like he makes a lot of searches with that IP address, and like it bombard our system, so we need something, so we have to block in that case on the basis of our IP address. And when we block on our IP address, there are the cases of the false positive, and we cannot do anything about it. So as I mentioned here on the second point, like there we have 20 services. So let's assume these 19 services are working when the user is logged in, and one service, that is of authentication service, is working when the user is not logged in. So it means that the login API, search API, let's consider that search API is somewhere like, so we have to mention, like we have to take care of it. Some APIs are going to work on the IP addresses, and some APIs are going to work on the user IDs. We have to figure this out. So we have to go with an hybrid approach. IP addresses when the user is not authenticated, and user ID when user is authenticated. Then it will be better. But when we are going to use an IP address, of course we will get some cases of false positives, but we have to deal with them. Now, let's second point comes how our interface of a rate limiter going to look. So rate limiter, it's going to give a boolean value that either this value is going to be true or false. If true, we'll pass it to our server. We can run the code logic. If it is false, we cannot run our code logic because it is going to be fail. Rate limiter takes 4 parameters: user ID, IP address, service, and request. User ID is a nullable field because it can exist, it cannot exist. Up to the service, we have to write a code logic later on. Now, comes to the point where to put our rate limiter. So we have multiple scenarios. So first of all, let's see if we put our rate limiter logic on the server level. So it means that where we write our code, in the same place we put our rate limiter logic. Now what will happen in that scenario? It will, if we discuss about the pros of that, the API, there is no API call involved, so it is going to be very fast. There is no latency, but like there is a latency of the code, but there is no API latency. Now if we discuss about the cons of it, then it is, the system is going to be very tightly coupled. Let me give you an example of it. So I mentioned service 1 and service 2. Now service 2 have lot of crons in it and very less user interaction. So like requests are coming from the user and rate limiter is going to be used, but not that much. Service 2 is basically majorly running crons. And now what we want to do, like there are some heavy crons that we want to run on the service 2. So we want to increase the size of the service 2. But do you need to increase the size of the rate limiter in that scenario? But rate limiter is of course attached with the service 2. Then we have to increase the size of the rate limiter as well. But we don't needed it. Because of that, we can say the system is tightly coupled. We cannot scale them independently. This is the one reason. Now, let's move to the option 2. That is going to be dedicated distributed rate limiter. So what it means that if there is user make a call to a load balancer, then the call will go to a rate limiter. So we'll mark it as action 1, action 2. The call will return back from the rate limiter. It is going to be true. And if it's going to true, then we'll pass it to the server, and the server will process and return to a load balancer, and then it will reach to a user. But if the request is not valid, the rate limiter will say it is not valid and just return it to a user. Simple. This is how this is the second approach. The pros of this whole system is that rate limiter can like upscale or downscale independently out of servers. The server can also upscale or downscale according to the traffic, so they are not dependent on each other. There is a con in the system is that it will increase the latency because there is an API call every single time to a rate limiter service that can make our whole process slow. Every single time we have to call a rate limiter service and we have to figure it out that this particular call is valid or not. Now move to the third approach, that is rate limiting with a caching. So what we can do in this caching part, what we'll do, we'll just put a cache on our load balancer. So it is going to be a simple, and we can implement it in multiple ways. Whatever seems easy, we can do it. I'll just take some of the examples what we are going to do in this. Now what we'll do, we'll just make a simple architecture as it was previous. The call will come to a load balancer, it will reach to a rate limiter, it comes back, and then it will reach to a server. And this important part is that what we are going to store in our load balancer cache, what we are going to store, we can just simply store a ID and epoch time till the time they are valid. So suppose if we have a request from 0 to 60 second and the user can send up to 10 requests in this whole time. So first request come up, there can be multiple ways to implement it. Let's take a simple example now. The first 10 requests, the request will come to a rate limiter. It will reach to a, it will be resolved by a rate limiter. Second also, so 10 requests will reach to a rate limiter. And after that, the rate limiter is going to say to our cache, it is just going to put a timestamp. See, now we are on the 40th second. This user sent us up to 10 requests. Still 20 seconds are left. And maybe there are chances that it will send more requests to me. So please load balancer, help me out and say no to that user from the load balancer itself. So what will happen? All the API, all the access calls that are going to be say false by the rate limiter, in this case load balancer is taking care of it. It is saying false from itself. Like the API calls are saved now and all the genuine users are going to reach to a rate limiter now. So we just process, like this can be a one solution. There can be other solution. Rate limiter previously only, like when the counter is 2, rate limiter push it to our load balancer, and rate limiter, what the rate limiter will do, the load balancer will increase the counter in the cache and it will say rate limiter you also increase the counter in the cache. There can be multiple scenarios. I also mentioned that we are using the write back cache, so you can study in my last video how we used it in our tinyURL. Now, so there can be scenarios where we can use it. So this is the final approach where we can put our rate limiter easily. Now comes to the last point of the DB choice. So DB choice is going to be pretty simple. That is going to be Redis. Algorithms in the next video. Now, why we are going to choose the Redis? Because Redis is going to be fast. First point. Second point is, I told you that we are going to use, like we want to scale our rate limiter independently. Now Redis also provides the distributed environment and we can also scale our Redis accordingly. Now these are the two reasons why we can use Redis in our system. Third point, we can also consider that Redis doesn't store any data in the hard disk. It is going to be fast because it stores the data in the RAM. So this is all for this video, and algorithms and whole design we're just going to see in our next video. So thank you for watching me. I hope you understanding the concepts till now, and let's meet in our next video where we see all these things. Thank you so much and bye bye.